This video is about the two other kinds of list abstract data types, unordered list ADTs and indexed list ADTs. The key property of the unordered and indexed list ADTs, as opposed to the ordered list ADT, is that in the unordered and indexed list ADTs, elements go where we put them or stay where we put them. So we specify exactly where we want an element to go, and it goes there, and the list does not try to automatically order them in some other way as it does with ordered lists. So because elements go exactly where we put them, and we may want fine control over where we put them, there are multiple add operations for an unordered or for an indexed list. For example, an unordered list might have an add to front, an add to rear, and an add after, so that we can say put something on the front, put something on the rear, or add something after some particular other element. Or we might have an insert before or add before, something like that. Then also we have remove and first and last, and is empty, and size, and contains, and other common operations. So let's see an example. So let's suppose that our list initially contains A and C, and then we call add to front to add a B, and so that's going to put the B here before the A, and then suppose that we call add after to say to add a T after the A. Then our list would look like this, and then let's suppose that we called add to rear to add an H, and then our list would look like this. And so we have the word batch. And then let's suppose that we were to call remove to tell it to remove the T, and then we would be left with BACH, as in Johann Sebastian Bach. So every time we place a letter or place something in the unordered list, we specified exactly where we wanted it to go in relation to other elements, and it was placed there. So the fact that we can specify where we want to place things at, and with a little bit of effort or using additional remove operations, we can remove them from various places as well, means that an unordered list is a very flexible ADT. We can use it to simulate a queue ADT by only adding to the front and removing from the rear. We can use it to simulate a stack ADT by only adding to the front and removing from the front. We can do many other things with it. So that covers unordered lists. Indexed lists are exactly like unordered lists, except that the elements are automatically sequentially numbered from the beginning, generally starting with 0. So let's redo our example with this as an indexed list. So initially, A would be element with number 0, and C would be the element with number 1. And then we call an add to front for B, and now the numbers change, and the index of B is 0, the index of A is 1, the index of C is 2. And then let's suppose that we say to add T after A. Now the index of that new letter T we added is going to be 2, and the index of C is going to be 3. Then if we say to add H at the end, then the index of that new H is going to be 4. And so somehow the indexes or indices magically stay up to date with the ordering of elements in the list. And again, the ordering is things are put exactly where we specify to put them. Now, in an index list, we have a concept of placing something or locating something by its index. That's what makes it an indexed list, in addition to having all the properties of an unordered list. And because of that, we now have new possibilities for our retrieval operations and removal operations. So for example, we could have an at index, which returns the element in a given index. So we could say at index 2, and that would return us t, or maybe it would be get index 2, and that would return t. We can also say something like remove index. And so we could say remove the element in index 2, and that would make the t go away, and everything else would be renumbered. And now we would be back to BACH before. And the reason we didn't get to BACH before was that I never removed the T for the index list case until then. And in some languages, we can even use array style references. So we could just say list sub 1, and that would give us the A. In fact, in Python, the basic list type implemented directly in the language is actually an indexed list, and so we can reference it with indices like this, and the indices are automatically updated just like a proper index list. And the Python list has other features as well that normal index list ADT does not offer. So in unordered lists, elements remain where, or elements are placed where we specify, as opposed to ordered lists where elements automatically go to the right place in comparison to other elements, for example, alphabetical order. In an index list, it's just like an ordered list, an unordered list, sorry, except that elements have a specified index that is their position, so they're automatically numbered with an index number like they were in an array. And again, because unordered and indexed lists let us put in things at different places or different ways, they have multiple add operations, whereas an ordered list only has a single add operation, which is going to automatically determine where to place the thing. So unordered and indexed lists, elements go exactly where we specify. Ordered lists, elements go where they're supposed to go according to the defined order on the list.